Welcome to Biota Live. I'm Tom Barbalet, and this evening, a number of topics, hopefully with Bruce Damer and potentially another person calling in. You too can call in. This is live radio, 646-200-0640. Or if you don't want to make a call to the US, that's the US number, there is a chat window available via the Biota podcast page, biota.org/podcast. Now, if you're listening to this for the first time, there's also a great deal of audio on that page, biota.org/podcast. I received a few emails this week from folks that had listened to the podcast for the first time and had downloaded some of the audio and burnt them to CDs and were catching up on what Biota was about and what artificial life was about in general. So the topic slated from the previous show was a discussion of the ultimate project. I'm hoping to have Bruce Damer call in to discuss that, and potentially also Jeffrey Ventrella and others. If you're an artificial life developer listening to this live, please feel free to call in. That number again, 646-200-0640. And if you're listening to this as part of the podcast, 8 p.m. Pacific on a Friday night, every Friday night, we hold Biota Live. And for the first Saturday of the month, we will do a specially timed one for European listeners as well. I think it's probably going to be about 10 a.m. or 11 a.m. Saturday Pacific, which should correspond with, I think, 8 p.m. Or 7 p.m. In mainland Europe, or for most of mainland Europe, which will enable you, if you are a European artificial life developer, to call in either via Skype or at least participate in the chat. Anyway, a number of bits of news. First, I'd like to start with congratulations to Dave Kerr and Margaret for the birth of their baby boy, Flint. Dave Kerr is a long-time Biota alumni. He featured, I think, on the first recorded podcast. There's a text interview of him as well available online, and he participated in the conversation. So it's wonderful that he and Margaret have had Flint. And news from the last show. There is going to be a Grey Thumb in London, and this is particularly important news. I have a caller. I believe it's Bruce Damer. I'll put him... Hello, Bruce. Hello, Bruce.
Hello, Tom. Good to be back.
Wonderful to talk to you. I think we may even have Jeffrey Ventrella coming in. The system is not behaving as well as it should. Would you like to say a few words with regards to Grey Thumb London while I try to get the system to behave a little better?
Absolutely. Well, what's interesting is I had planned to go to London to start a PhD program, and we had gotten last week Justin from London, who had been on the call last week, guest, had been at a Grey Thumb meeting in Boston, was so impressed by it that when he heard I was coming to London, he said, was there any way we could sort of start a Grey Thumb in London and you could be the first speaker? So I thought, this is marvelous. This is a marvelous... when you go on a trip, you should try to do more than one thing. And it turns out that after the London trip, I'm going to Boston to attend a Grey Thumb meeting in Boston.
So you're almost doing it in reverse. You're doing the London one first, having not experienced the original Grey Thumb, and then you're turning around and doing the original Grey Thumb.
That's right. So what we're doing now is basically the Grey Thumb people are meeting on Monday to put together a kind of a franchising package of, this is Grey Thumb, this is what it's about, this is the logo we're using. There's a model for this, which is the DorkBot community. You can go to dorkbot.org, and I think they're in 60 cities now. But, these clubs that meet, and it's a phenomenal way to spread ideas, and DorkBot's a great example to copy.
Yes, I got an email from Jason Evans. I believe Jason's in Brighton, and he was interested in setting up a Grey Thumb Brighton. And what fascinated me about, I guess, when I picked up the Biota mailing list maybe 18 months ago, I went through the list of, regions and locations that the email addresses were connected with. and I came down to a short list of more than a dozen locations worldwide that would be ideally, located in terms of, I think, having more than 10 people on the Biota mailing list associated with the regions. I think there were about a dozen in the U.S. Well, actually, I should say North America because Montreal was one of them. Obviously,
the Netherlands is probably a hotbed, too.
Definitely. Germany was one in the Bonn area. I actually tracked down the various ISPs and institutions that they were associated with. I think I even thought about creating mini mailing lists at the time. But obviously the podcast is a great way to evangelize the likes of Grey Thumb. And for folks listening to this podcast, the other areas were parts of Australia, Japan. I mean, pretty well all over the world I found these epicenters. And if you live in a remote part of the world or even a mildly populated part of the world with a university or two within probably an hour's drive, there could be a likelihood that you could set up a Grey Thumb group relatively successfully. I mean, we are even pondering that perhaps the Grey Thumb Las Vegas may take off after Silicon Valley. So I think there are a wide variety of locations. I probably should also state that I'm speaking to you all from Las Vegas currently. But I think there are a wide variety of locations internationally, and the Grey Thumb model is just so grassroots viral that I think it lends itself to the broader artificial life community very well. Now,
coming back from London and Boston, Grey Thumb, I'll want to have one in our area in Silicon Valley, San Francisco.
Definitely. Now, I believe we may have another caller, so I'm just going to try and pick up this other caller.
Hello.
Hello.
It's Jeffrey.
Hi, Jeffrey Ventrella. Good to talk to you.
Oh, you got me. I tried a couple of times before.
Your number isn't coming up for some reason. The system's still a little buggy, but it's wonderful to have you on the line.
Are you there, Bruce?
I'm here. Hello, Jeffrey.
Hi, Bruce.
Now, we did receive some complaints with regards to Bruce's levels last podcast, so I'm not sure what he can do to improve his levels.
I bought a new headset. How is it sounding?
You're still a little bit softer, but hopefully what we'll do is, we'll get you more impassioned so you'll talk louder.
Yeah.
All right.
Coffee.
I've got a cup in my hand.
So we were just talking about the Grey Thumb model, Jeffrey, in terms of bringing it to Silicon Valley, and I know you have friends in a wide variety of Silicon Valley communities that would probably be very receptive to a Grey Thumb-like group. Would you want to be the first speaker if Bruce was to start up a Grey Thumb Silicon Valley?
Sure, I'd want to learn a little bit more about it. I've just recently heard about it from you guys, but so far it sounds cool.
So in 30 seconds, Bruce, if you were going to evangelize Grey Thumb to Jeffrey, what would you say?
A homebrew club for artificial life developers.
Yeah, I heard you compared it to Dorkbot, so I got that connection. Yeah.
But I think what's even more interesting about the Grey Thumb phenomenon in Boston is probably now, and I speak from absolutely no experience, but from what I've heard, a minority of the folk who actually attend Grey Thumb are what we would probably call traditional artificial life developers. Mm-hmm. A majority of the people that are coming are either academic biologists, mathematicians, these are all the fringes that kind of vein into artificial life. Plus they've got lawyers and just generalist hobbyists and interested folk that come along as well. They have some venture capital people. I mean, they have a wide variety of people that attend. And I think that's what's particularly exciting about the Grey Thumb model coming out of Boston is it was, 3-5 guys used to get together over beers and talk about artificial life that then created this community almost instantly.
Mm. Cool.
So anyway, the topic I had one last thing that I wanted to mention, and that's that the Artificial Life 11 conference is going to be going on in the UK this year in August, and I thought that was something, although they're in Southampton, my UK geography isn't as good as it once was, but I think that should be an easy dray trip perhaps for Grey Thumb London, or vice versa. Maybe some of the Southampton attendees could go to a Grey Thumb London especially for it. In terms of folk that are listening to this podcast, you may actually be in the UK over that time, Bruce.
I might, depend on when the doctoral program meetings happen.
So what I was going to offer to the greater podcasting or the greater listening community was that we would really like to have someone on the ground with an MP3 recorder actually talking to people at Artificial Life 11. And if that sounds like something that would interest you, please get in contact with me. Maybe Justin Lyon, who unfortunately couldn't make it this evening, I believe he's on a flight, might be interested in doing that. But I'm sure we could provide an MP3 recorder for folks interested. And if we could have a roving Biota interviewer, that would be a wonderful thing.
Sounds great.
So anyway, the topic this evening was going to be about Bruce's ultimate PhD project, but it's kind of moved in a wide variety of directions. And I think the nature of this podcast, or the nature of this live radio show, moreover, is going to be just tracing the loose ends that are left after each live show concludes. But from discussing the ultimate project, Jeffrey, you got in contact with me, I think, pretty soon after the last one was recorded, and said that you were interested in talking about ideas in open source and moving an existing project into open source. And I think that vends into some of the ideas that Bruce was having with regards to his ultimate project as well.
Yeah.
So,
go ahead.
No, please continue.
Well, it kind of started when actually you were interviewing me and you asked if I was going to make gene pool open source, and I didn't really have an answer to it. And you know, the more I work in this industry and see the way things are going, I think that's really the best thing. And in fact, my 2 years of experience at Linden Lab working on Second Life really got that deeper into my philosophical fiber, the idea of opening your code and having the community involved. I think that's when big things happen. So I've been brewing up a lot of ideas during that time. I'd like to hear more about what Bruce is thinking, and we'll compare notes.
Sure. Jeffrey, what are you up to these days? Are you still at Linden?
No, I'm not at Linden at the moment. I'm doing some little contracting things here and there, and I'm developing a new version of Gene Pool as we speak, and getting ready for some other new things down the road.
So in constructing the ideas for this particular show, I looked at 5 areas that I would consider critical in creating an artificial life project, all of which are applicable to our 3 experiences. And this, I think, may make it easier for a generalist audience or folk who are thinking about either joining an artificial life project or starting one of their own. And I think the most critical thing is the seed idea, in terms of just having a rough idea and something that you are excited about, a kind of initial excitement. And I think a critical point, which will come into the discussion with regards to Bruce's PhD project, is the time frame. Both how much time you have available to work on it, but also whether you have a finite time frame in terms of getting achievable things by certain dates. The third is what I'm calling the manifesto, but it's fundamentally documentation. I know, Jeffrey, you've published papers as documentation, you've had internal documentation, so there's a wide variety of ways that documentation associated with projects comes together. The fourth is the code, which is either closed, open, combination of both, now increasingly even more abstract in terms of scripting, and we'll talk a little bit about that as well. And the final point is potential collaboration. Does some of the project already exist? Does a majority of the project already exist? Do you want people contributing from the get-go? Do you want it to be an isolated project? Those kind of ideas. And this was my initial kind of sketch of the way that we could take this. So in terms of the seed idea, Jeffrey, you've had a number of artificial life projects, but I think probably you're best known for Darwin Pond Gene Pool as a kind of collective project. How would you characterize the kind of seed idea of that project and how you came about developing it?
Did you say seed idea, like S-E-E-D?
Yes.
Yeah. Oh gosh, I think that, like many other things in the late 80s and early 90s, just the idea of genetic algorithms, connecting that idea with animation and organic and image making, so many things have come out of that, and are still coming out of that, of taking that kind of technology and those ideas. So it really kind of sprang from that. But one thing led to another. As you know, I worked on Darwin Pond at Rocket Science, and then I got the IP from that, and then I developed Gene Pool, and that was 10 years ago, and it's been sort of sitting kind of latent for a while, and I'm finally getting back to it.
Because I think, personally, looking at Gene Pool, the aesthetic is so unique in some regard. In terms of that aesthetic, in terms of the idea of the creatures moving in fluids, the way they moved, these kind of things, the colors, just the appearance of it, was that at the very start, or was that something that came through almost storyboarding?
Oh no, that was at the very start, but it was. I have an art background, so usually when I'm working on some programming project, there's always something visual. I try to make it visually compelling from the start, not only as the ultimate purpose, but that's what gets me going. That's what gets me excited about working on it. So right from the start, I was thinking about beautiful undersea creatures, and that's been my muse for the whole time. And I haven't quite reached it. It's kind of a holy grail, but I keep thinking about the amazing things happening underwater. And I have yet to go to Hawaii and go scuba diving or snorkeling. And I'm sure that once I do, I will be completely transformed, and I'll spend the rest of my life working on the next version of Gene Pool, and I won't eat or sleep, because I know that there's just so much more amazing stuff down in there. But that's my muse. That's the characteristic of the seed idea that I wanted to get through as your. And I think a lot of people. I think a lot of other people share that same feeling.
Certainly, I think that's the element that I'm trying to capture with regards to that. Now, in terms of time frame, when you started work with this, you were originally working within a corporate entity, and then you moved it out into a personal project. Can you discuss the differences in terms of time frame from a corporate entity to a personal project?
Time frame meaning how fast the work goes, or how fast the work needs to go?
A little bit of both. Time in general.
Sure. Well, actually, it actually started even earlier than that. I was at UCSD in San Diego teaching a course in C programming and artificial life and CAD. I was teaching a few classes there as a visiting professor, and I actually made the first version there, a very crude thing, which wasn't really ready to show. And then when I was at MIT, I developed it a little bit further and made a couple of video clips of it. And then once I moved to San Francisco and started working at Rocket Science, I developed more there. I actually forgot your question.
So there's an idea of time frame which is different in a kind of corporate setting versus the personal project versus what Bruce is talking about with regards to a PhD program. And then the point that I wanted to make in that context is you can create projects with the view that they're going to be passed on in a specific time frame to another group of people as well. And the idea of inheritance and these kind of things is also part of things like Darwin bots, for example. Yeah. Well, the time frame in academia is different than the time frame in corporate setting, which is, again, different than your personal time frame. But it sounds like you guys are thinking, and I'm still just learning about what you're thinking about, but you're actually thinking about creating a kind of a structure over time that defines the way this evolves over time. Is that correct? You're looking at ways for people to build on each other's work? That's an option, but I think it's in fact a far broader thing. In Bruce's context, I believe, and I'm speaking here for him, and he will butt in, I'm sure, is the idea that he's doing a PhD program, but he wants something that has legs following the PhD program. Is that correct, Bruce?
Yeah, I like you, Jeffrey, have seen so many of this brilliant work come and go over the years. Yeah. And everything is in its own petri dish, if we excuse the metaphor, and it exists in its own scene craft, and when the project, when you run out of energy, time, or funds, it falls back. And I've recently accepted an appointment at the Institute for Advanced Study in Princeton, and I'm working with Pete Hutt, who's a professor there. He's an astrophysicist, and we're trying to also come up with a project. But what happened at the end of the year, I had applied for a PhD program at the Smart Lab at the University of East London, which is a new campus in London in the Docklands. It's all high-tech, brand-new buildings. And they offer doctoral programs for mid-career people with a lot of stuff they've done, and over about a 2 to 3 year period going to and from London and having local advisors. And so it's self-directed research. And what I've got in terms of support, I've got some corporate support from my own company. We, as you know, Digital Space, we do contract work for NASA. And I've got a little bit of continuing education dollars in the company, so I've got it's in a way a company project because we could develop technology we could use because we're all open source. We could use it for NASA for evolving robotics that could walk on the surface of an asteroid in low gravity, and then it's an academic effort in that I'm going to be doing it as a peer-reviewed piece of work. And I'm recruiting a committee of advisors that will look at the work, and I would love it if you guys are on that committee, and so that there's an external group of practitioners and also institutions, so that it has that academic element to it, and then it has the personal element in that it's a self-directed research project I'll do from the farm down here in the Santa Cruz Mountains. So it's a blend of all three elements, and I've got several years to do this, and I have the ability to organize conferences and things, although that sucks all your time down, so I could help make it a community effort. And the one thing, if I can sort of, all that I know right now, what I'd like to work on is that we need a framework in the artificial life movement where, and picture this, creatures from gene pool working in the back end without being in their scene graph, but somehow working in the abstract, could talk to creatures, could talk to noble apes, working in the abstract, dissociated from their scene graphs, sending XML or whatever other protocol, and somehow there's a separate set of viewers, a 3D viewer or a 2D viewer can look into that system at some point in the system, which may be spread across a grid of machines or a grid of processors, so that you decouple the scene graph from the actual process, and you separate the very skilled viewer builders like John Klein's Breve, which is another open source viewer with physics with 3D, or Digital Spaces, which is our solution that NASA paid us to build. These all become viewer platforms, but they also provide scene graph services for the critters, if you will, underneath. But the critters underneath live in the architecture of the internet, and they're independent of the rendering capacity of that render their physical universes. And I still, beyond that, I don't have any specific understanding of how you would implement such a thing or do an experiment to show that this could work, because I haven't written a line of code in 13 years, and I'm completely out of date. I've directed software teams for 13 years, but I've not written a line of code. So anyway, that's the hand-waving vision for leaving something behind after this work is done.
That sounds good. It sounds like when you talk about scene graph, you're decoupling the visuals or the viewer from the simulation or from the computational aspect. Sounds like.
Yeah.
I think there are other decouplings as well. Like you can decouple genetics from physics, and you can decouple physics from brain. I think there are these various emergent levels which, in an object-oriented sense, in an interface computing sense, you can decouple, and that would make this very modular and scalable.
I mean, ultimately what Bruce is talking about is the interfaces.
Yeah.
He's talking about the interfaces, as you're saying, brain genetics, bodies, viewers,
Physics.
servers, physics. These are all interface layers. And then it's the responsibility of the individual simulators to say, well, okay, I'm doing, for example, the weather and the landscape physics and these kind of things. So I write the interface that abuts to communicating with the servers or communicating with the scene graphs and render this and these kind of things. So to bring it back more to a kind of generalist audience, I think you're also looking to create a project that demonstrates this as well, Bruce, aren't you?
Yeah, that by the end of 2 to 3 years, either working with, ideally, I'd like to work with a couple of existing active artificial life developments, somebody who's, passionately building their system, that in a sense it's almost like the Watson, the Alexander Bell experiment of, Watson, come here, I need you. When the connection happens between the two A-Life systems and the protocol starts working, and they realize, wait a minute, we can live in the same space, and then you have this push to the network effect, and then have a competent viewer platform, regardless of whether it's ours or John Klein's or somebody's, to actually represent what is going on in that communication and the physics, as you say, the genotype, phenotype, the brain action, and it's a hard problem, but when it's cracked, everyone can register their creatures into that layer, and then the viewers will get stronger and more powerful, and the algorithms that use all these multi-core processors will be developed within that matrix of A-Life. The generic simulation gel will map itself onto the multi-core revolution, and you'll start to see collective efforts rather than separate efforts.
Do you think it starts with a single interface, Bruce, like with regards to the interface to the scene graph, or do you see it as being all interfaces defined through some shared protocol?
I think we need a shared protocol, but we need to do it in small, manageable bites. So, for instance, you have a very simple way to describe a physical scene that's just a pile of XML or a bunch of Python that's tied to a pile of XML, some kind of scripting language everyone understands. And then you instance two creatures that are from different A-Life systems with different genes, brains, and phenotypes. And suddenly they're starting to interact, and they'll interact with the physics is a simulation in the background, but then the physics interrogates the scene, the 3D scene graph, and the renderer to calibrate itself, perhaps, or not. But the physics, at least in the background, can say, I'm close to you, or I'm right next to you, or I'm within sight of you, within sensing range of you. And then two very different artificial life systems start to interact within a visual scene. That would be a dream come true.
I think certainly the problem to date has always been the overhead associated with this, and this even comes through the recent chat with John Klein. When I say recent, it's probably about 4 months ago now. But when he talked about implementing Python specifically with Breve and the problems that he had in terms of attaching Breve to Python for a wide variety of platforms. So I think that's always been, particularly in my discussions with Gerald, for example, Gerald de Jong, with regards to his Darwin at Home, and when he restarted Darwin at Home and started again with the base physics, my initial communication to him was with regards to him perhaps adopting Breve or something else. And it's the pickup, unfortunately. It's the pickup both in terms of physical code that has to compile and also in terms of kind of intercompatibility issues and things like that. So it's a really quite a non-trivial problem and could easily be the basis, irrespective of a simulation project, of a 3-year PhD project. Now, in terms of the idea of a manifesto or documentation, this is something that I wanted to discuss, and perhaps we'll return to the time frame. In terms of creating this idea of interfaces, which is relatively abstract in terms of creating your own artificial life simulation, for example, but if we look at the interfaces, the code itself is part of the manifesto. It's part of the demonstration component. Now, how do you think, in terms of documentation and in terms of gelling the seed idea, how do you think you could do that with documentation in a manifesto for the spruce?
Well, I think this will all come out of when I test the idea at the Gray Thumb group on March 3rd in Boston. I mean, those guys are hard-nosed practitioners, and if it really comes down to, it's almost like when Washington convened the very hard-headed independent representatives of the states, the 13 colonies. And that first speech that he gave as to why they should work together was very well crafted, and the fellow was a great diplomat, but he was basically pretty firm on why working together was a good idea. And over time, Washington basically he sat through most of the meetings saying very little. He actually felt intellectually inferior to a lot of the men that were in the room because they had college educations and he didn't. They were well read.
In terms of two potential prodding stakes with regards to this, the first, I think, is potentially industry funding, but the second, which I think is probably far more serious, is the fact that Microsoft Research is already creating an AI simulation environment which is heavily applicable to artificial life, and it could be very soon that there is a .NET version of this that we will all be consuming. So I think there are two potential prodding stakes. If we look at the idea of industry coming in and offering some degree of support with regards to this, certainly Bruce and I have had extended correspondence with Justin Lyon with regards to the enterprise interests in artificial life over the past week alone, and he's going to be a fascinating guest to have back on to talk about that formally. But Bruce, do you want to talk a little bit about the potential for industry funding for this kind of group collaboration?
I have 10 years of background of getting governments to fund R&D. I've done 21 projects since 2000, whether it be pseudo-government organizations like Raytheon or NASA, which is real government, or recently the European Space Agency. And it's not hard for me to imagine that I can go back to all my contacts at DARPA and various government agencies and show examples of what is working and get pure research dollars for continuing the work. And there's just a number of areas that I could go. I'm keynoting and hosting a conference on the intersection of virtual worlds and space starting a week from tomorrow. And I've got this huge group of people coming, 70 people coming in, and some of them are very focused on adapting complex systems. And Will Wright is going to be there showing SPORE and things like that. We have a 3-star general from the Air Force and a 2-star general who heads NASA Ames Research Center. And all of these guys are primed for the message that virtual environments are important. They're already investing in it. But we can also give them the spin that virtual environments with biologically inspired adaptive systems and evolution are going to be important for them too. And I don't have any doubt that I can get funding. And in fact, one of the reasons I'm enrolling in this doctoral program is so that 2-3 years down the line I can apply as a PI on larger grants that require a PhD. And by recruiting Stanford and the Institute for Advanced Studies and other schools to advise this work, I also expose them to this work and expose them to co-grant writing opportunities as well. So I think all boats can rise out of this effort, multi-pronged effort, and we don't have to go to venture capital, which Jeffrey can give us more history of. It's very finicky and takes a chunk out of things. We can go to pure research dollars, which I think is the safer, longer-term way to get big platforms built.
Do you want to talk to that, Jeffrey?
Only to say that I'm all for avoiding venture capital if we can.
Yes, I've got to say an amen to that as well from my own experience, although I'm sure Justin is going to come and evangelize us to the contrary in an upcoming show. I think the interesting component that certainly my own development has been a part of is the open source community and how that has assisted in many regards, and also been an interface into the likes of Intel and Apple from the previous show. So my thinking is also that there would be industry support as well with regards to once the thing got up and running. Do you want to talk a little bit about that too, Bruce?
Oh, absolutely. I think that because of our last 10 or 12 years in the Biota project, Biota 1 Digital Versus was well sponsored by some of the larger companies that we're going to go back to. It was sponsored by Microsoft and Intel and SGI, which is in no position to sponsor anything at the moment. Sun Microsystems, and there were universities involved, and there just is no doubt in my mind that this meme, if you will, is still very powerfully of interest, even though they may not understand the real applications that well. But I think that once you get proofs of concept in place and you get an evangelist or two out there, and as we get older, we get into our 40s and then into our 50s, our peers who grew up and struggled the same struggles we did are heading departments, they're heading granting agencies, they're vice presidents of research. It just happened that you hit it at the right time and you can really get something done. And it should be done as a consortium-type effort.
Certainly, and this links in potentially into the Microsoft component, but I also wanted to talk a little bit about the code and the interfaces with regards to open source and non-open source. And I think, Jeffrey, you had some questions with regards to and I think this is applicable to the generalist audience as well, about how open source works in a kind of practical level. Do you want to put those questions out to Bruce and me?
Yeah, I'm starting to look into it more, and what I'm really interested in is this sort of hybrid approach of keeping certain things. I'm creating a lot of static. I hope you're not hearing it.
It doesn't matter.
Oh, okay, all right, it's fine. Of having certain pieces of code that are undercover and opening others up. But I actually, talking about interfaces, it's making me think a lot more about that paradigm, and I've always thought this, and I'm thinking even more now that designing the interfaces, the APIs between the different components of the system is a great way to start. And in fact, if you can just do that and let everything be open and undecided, that I think that can be a good way to get things going. Of course, you need some code to show the beef at the beginning and to have things working. But I'm thinking even the glue, even what you think of as the glue, like you might think of Python or some scripting language as the glue between the different pieces, even that can be something that's connected with interfaces. So that's sounding a little abstract, but I think you know what I mean.
One of the just as a cut down into the coding level, NASA, when they came to us, they said they wanted open source, they wanted a physics-based, very high-performance environment, so we built digital spaces. And then they came to us and said, we don't want to be writing code in this environment. We don't be writing C or C++. We want you to adopt common scripting languages. So they wanted a number of things. They want Tickle, believe it or not. They wanted XML. They wanted Python. They wanted Scheme as well down the road. So we actually built XML interface that everything's based on, and then we built Python. And we've got 3 projects now where people are just going and writing Python and doing pretty much about 60-70% of the real code that runs the virtual rovers, the lunar rovers. One guy has the rovers deforming the mesh and doing bulldozing, which we thought, oh, well, there's proof in the pudding. He did a core engine change using script.
Well, what if you don't require it to be Python only? What if you can say whatever scripting language you want to use as long as it follows this interface?
Right.
And that allows people to use the language of their choice.
And the idea there was that since you can drive the entire engine through XML, that you could just hurl XML at it. You could have the City University of New York project. What they're doing is they're taking a sound generator, a procedural sound generator that runs as a headless C application. It's really highly regarded in the music field, and they're hurling XML and or Python at digital spaces to ask it if a ball has collided with a chime. Getting something back, and then they're generating the sound. So that's one of the projects. But they basically said, well, either one. If we really wanted the project that we may be doing this year with a lunar excavator, the guys want Tickle. And you think, well, why would you want Tickle? Well, it turns out there's a bunch of really good hardware motion controllers for physical robots that have Tickle interfaces. So each new scripting language we can integrate into the core so that it's efficient with about a 3 or 4 week job at this point. So the idea is ecumenical support for scripting as much as possible.
So if we can return to more abstract ideas of what open source is, when I interviewed Steve Grand, we talked quite a bit about open source in the interview, particularly with regards to his views on open source and the problems that he'd experienced with regards to developing creatures and control of ideas and these kind of things. It didn't actually go out in the final interview because I wanted to have an opportunity to have him in this kind of environment to actually talk on it, and hopefully we'll have Steve on in the near future to talk about open source in this context.
Yeah, it'd be great to hear him on that.
His view, I think, is probably similar to your original view, Jeffrey, that open source was fundamentally about a loss of control in terms of putting something out there and not really having any control or motivating influence over the ideas. And my own experience has been the exact opposite of that in some regard, that when you put something out open source, as opposed to, for example, a proprietary or venture-funded model, you have control far greater than you would have in a kind of long-term proprietary or venture-funded, proprietary/venture-funded model. Because ultimately, whilst you want to continue to motivate development, you are the primary source, and when you get tired or have, other folks that are interested in taking it in different directions, you can then, talk to them and negotiate, how it's going to work out. And it's a lot more about actually maintaining primary connection, and maybe control is the wrong word, in an open source environment than perhaps experiences such as, Steve had with regards to the creatures development and perhaps you've had in the past. So for people that haven't kind of dabbled in open source yet, it may appear somewhat artificially to be about putting the source code out there and then having it stolen and ripped off and, being released and all this kind of stuff by, third parties or what have you. My experience, while some of that has gone on, has in general been extraordinarily positive, and in terms of maintaining an active development and also passing a development that I'm not particularly interested in, the Linux version, for example, off on to people that are particularly passionate about it. And it's a funny paradox, because on one side you have huge corporations, and I talked a little bit about this last week, but fundamentally you're dealing with individual engineers that are very respective and responsive with regards to what they're doing and their contribution back into the project. So I don't know, it's difficult to describe because there are these kind of idiomatic components to it, but certainly I don't feel that I have lost out in any great regard with regards to putting it under an open source license. It wasn't originally under an open source license, but the source code was available. And certainly in terms of my ability to interact with the multi-core processor team at Intel and a wide variety of teams at Apple, and just talking to, young engineers that are very excited about the project and folks at universities that have picked up the project, I don't think, it could have happened if it was closed source, but the speed at which they picked it up and the speed at which they got in communication and all these elements, I don't think would have happened in the same way if it was closed source. Now, you mentioned, for example, SourceForge. I have mixed feelings with regards to SourceForge, but it is very useful in terms of actually recruiting people. Mm-hmm. And if I look at the two, I'm naming two people here because they come to the front of my mind, but Pedro, who has appeared on a previous podcast, I think he was on the open source one for the Biota Conversations, and Riddle, who is now a master's student in the US. These are two people who came to me through SourceForge. Riddle had a particular interest in the Windows development and wanted to look at some of the high-level stuff and also integrating his own, AI models. And Pedro had an interest in the Linux development. And these are two people who had different interests in the project, picked it up and took it in their own direction and then gave immediate feedback. And also, it's part of a community. Similarly, the folks at Intel and Apple that have gotten involved, and at Apple in particular, there have been many different folks at many different sections, and even sections that I didn't know were using it have contacted me and said, we've, done this with it, and there's all this kind of constant communication and collaboration. And also, Apple in particular has actively evangelized Noble Ape to their third-party developers. So I'll get other people coming in. So in terms of this, it's a difficult idea because, ultimately one would want to make what one does with artificial life one's livelihood. And, there's always questions of...
Yes, but I think to your point, one's livelihood requires a networked community of people and collaborators.
Very much so.
So I think that open source is just that very paradigm shift that puts you into that networked community. I think it's really a social phenomenon as much as it is a technical one.
And the ideas, the thing that I'm really starting to realize, mainly through things like podcasting, doing these abstract things, is the ideas don't exist in the code. The ideas are something that's meta to the code, and whilst the ideas in some regard are described in the code, the ability to hear people's voices or, the sense of community and these kind of things, and the emails and all these things are as much a part of the idea as the code itself. So if you think, well, all my ideas are in the code, and if I'm giving away the code, then I'm giving away all my ideas. No. There's something actually quite meta to that, which is what's fascinated me, particularly doing these podcasts, is that it's actually a different kind of communication. I'm putting the same ideas out that people may get through, playing with gene pool or looking at digital space, but actually it's through a different medium, so different people are receptive to it.
Mm-hmm.
Bruce, I've been rapping for a while. Do you want to add something?
I think that it'll come down to the trust of the players. That's why I was giving the example of Washington and the heads of the colonies. If you go into a very, very energized but opinionated in terms of approach group like Grey Thumb, and you can convince two or three of them to try an experiment where their systems communicate.
Mm-hmm.
And then you can convince somebody else to become, where they can become servers and players in a larger thing, then you've done it. And it really would come down to just that personal trust that this is a worthwhile thing to do, and they believe in the vision. And from that point on, it's fueling them. It's providing them, if they want funding, it's providing them funding if they want end-user applications so that it justifies their personal value in it, then you try to find end-user applications. If they want, more Grey Thumb groups or the more volunteers, you find them more volunteers. But as long as you can keep, and architecture sessions, to keep the vision going, so that people don't paint each other into a corner. So I think it all comes down to that small working group of people who build outward. And, of course, it's all open source. And Jeffrey, does that make sense to you?
Oh, I'm sorry. I didn't hear every bit of that, but...
It's that initial group of people that trust each other enough to work together.
Oh, yeah. It's you sort of start a core trust network, and trust can be contagious.
Well,
so you can build on that.
We have a geographically divergent but very shared trust, if that's the word we're going to use, oriented community. And I think that's what fascinates me when we talk about regional grey thumbs, when we talk about the effect of the podcast. All these things are about reaching out to people that are either contemporary hobbyists, old hobbyists, academics, users, muses, philosophers, all these people kind of coming together. Now, with a kind of reducing time, Jeffrey, in terms of moving what you're doing currently into a more open environment, what is your thinking currently?
Well, I think it might be too soon for me to really say that I have any plans in particular. Although what I am doing with GenePool, I'm building it out. I'm basically building everything from scratch. I'm hardly using any of the old code, and I'm building it in a much more object-oriented, interfacey way. And so my plan is that once I add a couple of extra features, I will then have a much more a modular piece of code that I can start playing around with in these ways. And admittedly, I need to do some more research into the whole open source mechanisms. Maybe I can learn some more from you as far as the different ways you can do that. But at this point, I'm still in the stage of sort of rewriting the code and preparing it for being able to be pulled apart in different ways.
Jeffrey, would it be interesting to you if I would offer our engineering support for if you had a gene pool where the creatures were sort of modularly separated in the new form you're picturing, that they could send and receive communications from our 3D open source front end, and you could represent them in there?
Sure. Let's talk about what you're building, so I can learn more about what you're doing. Sounds good.
If you go to digitalspace.com, we did 1.0 developer release on November 30th, and the whole thing is there. All the code base examples, tutorials.
Mm-hmm.
It's all there to download. It's like there's a C, C++ interface, an XML interface, and a Python interface.
Mm-hmm.
I mean, one of the interesting aspects about returning to old code, particularly with new compilers and these kind of things, is that you have to do relatively thorough rewrites anyway. And I think certainly there are a number of historical artificial life projects that may now be dusty old code somewhere, that through trying to get it to compile on new compilers and these kind of things, historical code will need to be rewritten anyway. I think what interests me, we've discussed this quite a bit, is the idea of scripting and how scripting comes into play. Mm-hmm. There are a number of low-level scripting languages. I know the game community uses, and I always mispronounce it. It could be, it's Lua, I think, or Lau.
Lua, I think is what most people call it.
Yeah. So, and that has always been pitched to me for Noble Ape in terms of its small compiler size, or compile size and interpretability and this kind of stuff. So I think probably a start would be some degree of surveying, which really goes back to the original aims of Biota at home in terms of where the state of the art is for contemporary projects. However, I think Bruce's view is that you start with a couple and from there momentum builds. I'm right in thinking that, aren't I, Bruce?
Yeah, if you can get two people who are in the right sort of period of their artificial life development lives and say, wouldn't be too hard, let's give it a try. And then others, what they've done.
I think that's a great idea. Like if you say, hey, if you can make it so I can have your gene pool swimbots floating around in my world and my critters hanging out in your world, let's try that and make that work. And I think a lot of really cool things come from that experiment. And I don't think it'll be hard, actually.
An example of this, Claude Lataude at University of Paris. You were at Virtual Worlds 2000 in Paris, right, Jeffrey?
Yeah, we were both there.
We were both there, and Claude was, this young, energetic researcher, and he was very interested in L systems. Well, what they did was they developed something called Darwin's Park.
Park.
It's wonderful. It's actually what we wanted to do with second rendition of Nerve Garden, but never did. It's a voxel-based L system growth environment where the minerals and light paths, photons affect the growth of nuts.
Nice.
Oh, it's beautiful work. And they did it in directly coding it onto Ogre 3D, which was the scene graph engine we chose. What he wants his student to do now is to dissociate the code for generating Darwin's Park plants and start sending to make it happen on any framework, in any 3D framework, so that you could have the swim bots swimming through L system generated landscapes or plants. When we start to combine those, the swim bots, they wanted to become polyvores and eat the leaves on these plants, and then there would be a way to control the explosion of polygon and the deterioration of frame rate, which happens in Darwin's Park pretty quickly.
Mm-hmm.
Frame rate is going.
The universal problem. Look, I don't want to stop the conversation currently, but we only have 3 minutes remaining. So would you both be available same time next week for a continuation of this?
I should be, as long as I'm not over at NASA, but I should be.
Jeffrey?
I think I might be. I'll have to check my schedule, but
not a problem. I'm looking forward to additional contributors as well. The number for folks interested in calling in 8 p.m. Pacific next Friday is 646-200-0640. The biota.org, biota.org/podcast will have links to everything mentioned this evening, including Jeffrey's work and Bruce's digital space and a wide variety of other things that have been discussed. I'd like to thank you both for appearing on Biota Live number 2. With less than a minute remaining, anything you'd like to conclude with, Jeffrey?
It's been a pleasure, and I'm looking forward to opening up. Terrific.
Bruce?
Oh, it's just great. It's great to have these discussions and to know that others can listen to them, and we can really bring this field alive.
Certainly, and for folks not able to call a US number, there is a chat window which enables you to contribute questions. Thank you very much for listening to Biota Live.